All right, welcome everyone to Get Up and Running with Containers and Amazon ECS. My name is Brent Langston, and I'm a senior developer advocate for Amazon Web Services. So today I want to talk about what is Amazon ECS and how do you get up and running? And then what is the ECS developer experience like? And I want to actually take you through a demo to kind of show you what that developer experience can be like. And then we'll talk about what we talked about, what we learned to wrap everything up. So, what is Amazon Elastic Container Service, or ECS? It's orchestration as a service. And you may have heard of orchestration in the past. You may have heard of Kubernetes. You may have heard of Mesos. You may have heard of Docker Swarm. Those other orchestrators are all orchestrators that you have to run yourself, and you have to become an expert in how to manage those orchestrators and how to fix them when they break. ECS is different because Amazon runs ECS for you. And because of that, you don't have to worry about fixing it if it breaks. We'll take care of that for you. You don't have to worry about how to upgrade it from one version to the next. We're taking care of that for you behind the scenes. All you have to do is use it. It's also flexible because you have lots of options available to you for how to schedule your jobs or tasks or services. And then you have options available to you for how they should be placed, what availability zone they should go in, and stuff like that. You can schedule long running applications that should just be on basically all the time, taking traffic, or you can schedule batch jobs that might only need to be triggered based on some event that occurs. Um, the nice thing about ECS is it's integrated with the AWS environment. So you're not having to build an entire ecosystem around your containers and your orchestrator. You instead get to use the best parts of AWS along with your containers. So instead of reinventing all of these wheels, we can just reach out and make use of them. We can make use of service discovery using Cloud Map. We get the best of breed load balancers by using ALB and NLB and just integrating directly with those. If we need storage, we can bring in an amazing storage solution called Elastic File System, EFS. So you get the idea. Instead of having to build all of these things, and again, then you have to manage each of those, we can actually do that for you just by integrating that service directly with ECS. It's extensible. It has APIs that you can talk to, and you can, of course, have third-party integration with. It's secure. Security is woven into the very fabric of everything that we do at AWS, and that's no different with ECS. We build in your own VPC so that your containers are running inside your private network. We also have a serverless offering. So along with ECS, you can have your containers running on your own EC2 instances. And maybe that's important to you because you want to have your own security hardening built in, or you want your own log forwarding built in, or you have some kind of compliance requirement. If not, then we also offer a serverless component called Fargate, where we'll actually manage all that compute plane for you. So with that compute plane, instead of you having to patch it, upgrade it, update it, and all that stuff, again, we'll take care of that for you, and it's one less thing for you to have to worry about. And by doing that, by taking all of these chores off your plate, you're left with just the part that matters most, just your application. And as long as you focus on your application, you'll be able to have more time to move faster and to make better improvements for your customers. We also have Amazon ECS Anywhere coming soon. And this is going to allow you to use compute wherever it happens to be and tie it in with the ECS orchestrator. And that way you can schedule services and jobs to run on your own compute, wherever it may be, even outside of AWS. So how do you get up and running? This is the basic process that a lot of companies have moved to. You might recognize it as, a DevOps process where you develop, you build, you release, and then you're left in this mode of operating. And then, of course, you go back to the beginning. If you have a new feature that you want to add, you develop the feature, you build it into your software, you put it through the release process, and then you, again, continue to operate it, maintain it, make sure that things are healthy. So how does all of this map in our world of AWS? Well, for develop, you would be writing code and you would be pushing it to a source repo. For build, you would be building and packaging. And again, in our situation, it's going to be with Docker, and we're probably going to be pushing to a registry like Amazon ECR. And then to release it, we would simply deploy using Amazon ECS, and then operating, we would be observing what's happening with Amazon CloudWatch. So these are all integration points, and these are all parts of the process that are very normal for people to follow. So with this process, we want you to be able to choose the right tool for the job, and you can decide how you want to get started. Getting started, these are just some of the ways that you can get started, but they're very, very simple. So just very basic, you can start with the management console. You can go to the ECS console and point and click your way into a running service. I'll jump to the bottom for a second and we'll talk about the Cloud Development Kit, CDK. And what this does is it allows us to combine familiar programming languages like Python or Node.js with the idea of building infrastructure as code. In this case, it's true code, Python or Node.js or some other languages, where we can actually write code that turns into infrastructure coming up. And what's nice is you don't have to know every last detail, because the CDK has a lot of best practices built in. What we want to focus on today is this middle one. This middle choice is the Copilot CLI. And what I like most about Copilot CLI is it gives us kind of the best from the top and bottom choices. So instead of us writing infrastructure as code, Copilot can do that for us. But also, it's as easy as poking around on the console and choosing our own path. So it walks us through the most common workflow to be able to get up and running very quickly, but it includes all the best practices like log aggregation and metrics gathering and all this other stuff just automatically. So we don't have to figure all that stuff out, and we don't have to understand how to build it. And that allows us, again, to spend more time just focusing on our application that we want to write and we want to release. So we're going to look at a demo, of course, but this is a walkthrough of what Copilot looks like. So you can see that we have just a very high-level set of commands, Copilot init, and then we might have sort of a medium tier of commands like Copilot service. So if we're going to focus on just initializing Copilot, we're going to start with Copilot init. And then if we're going to manage one of the running services, we're going to use Copilot service. Copilot focuses on those steps: develop, release, and operate. Develop, very simple, very simple tasks by being able to just be embedded into our code. And that way it's portable. If you have 2 developers or 3 developers and they all need to be able to use Copilot, they can all share the same code manifest. And it's just Copilot lives with the code with the code. Release, Copilot takes charge of the release process, either manually by doing Copilot service deploy, or it can actually build a CI/CD pipeline for us. And ultimately, that's what most developers want, is they want the pipeline to take care of all of the release process, and all they care about is pushing to Git and having their, as soon as their code goes to their Git repo, then it triggers the release process. And then operationally, what does Copilot bring to the table? Well, it gives us built-in things like auto scaling, it gives us metric alarms, it gives us log aggregation, and so on. And these are all things, again, we don't have to build. So we can just take advantage of Copilot's built-in intelligence for doing these things. Okay, so let's dive in and let's take a look at a demo of Copilot. Okay, so for the demo, I want to walk you through a portion of ECS workshop, and we're going to follow the Copilot instructions just so that we understand how Copilot can help you get up and running. So I've already done some of this preliminary stuff, and you can walk through this on your own if you want. There's an introduction section. There's a start the workshop that'll help you build a workspace like the one I'm going to be using. And then we're going to get into deploying microservices to ECS and installing and configuring tools. I've done this, and you'll notice, by the way, if you're using the workshop, there's a set of tabs that you can follow, and I'm following the Copilot CLI. The whole way through the workshop, I'll be using the Copilot tabs. So I've installed and configured the tools. I've cloned the service repo, and when it comes to the platform, I've done this too, but I feel like I want to point out that there's nothing to do with Copilot. So I want to kind of stop here and talk about this for just a second, because normally what you have to do is you have to build this environment. And this is an example of what we might build to host our containers. We might build our own private VPC, and it might have a set of public subnets and a set of private subnets. There might be some EC2 instances that we would have to bring up. We would have to bring up an ALB and have it terminate into the public subnets. There might be a bastion. There might be a NAT gateway. We'd have to get all of our subnet numbering correct. We'd have to build security groups and have those be applied correctly. I keep saying might, because with Copilot, I don't have to do any of this. Now, that's not to say this doesn't get done. It definitely happens, but I don't have to figure it out. I get to stay focused on just my application, and Copilot is going to take care of doing this for me behind the scenes. So for that reason, when you look at the Copilot CLI path, we actually don't have to do anything here. We get to skip over this particular step. And I think that's really cool. So we then move on to building the environment. And the environment might normally be, you might have an environment for dev, an environment for staging, and maybe one for production. And so what we just looked at, instead of even thinking about building it once, I might actually have to build it 3 times. But again, Copilot will take care of that for me. So it'll build me an environment as needed. So I don't have to worry about doing any of this with Copilot. So we're just going to move on to, how do I deploy my first application? I have 3 applications here that we can deploy. The first one is a front end. The name, as the name implies, ECS demo front end. And then the other 2 are backend APIs. And this is a very common, very normal pattern of applications to deploy. And let's talk about some terminology for a second, because I've said application, I think I've said service. So when I say these words, what am I really referring to? The way I think about it, and the way Copilot names it, an application is a set of services. The application is often designed to still do one thing. So you might have an application that is your web e-commerce store, and that's going to have a front end, but it might also have a service for your catalog, and it might also have a service for your pricing, and it might also have a service for your customers to be able to log in. So those services work collectively together to provide the application. So the application is the collection of services. And then when it comes to the services, there are different types. There are front ends, services that need to take traffic from the outside, and those typically are fronted by a load balancer. So you'll see that we'll have a service type, the load balanced web service. But then there's also just services that run kind of behind the scenes that other services need to talk to. So our front end might need to talk to one of these back end services to get more information. So our front end in our store example might need to talk to the catalog service to be able to see what's in inventory. That's something that we often refer to as a back end API. It typically doesn't need a load balancer, but it still needs to stay up and running and healthy. So there's a lot of characteristics that we still want with a backend service, but just not the access from the outside. So we're going to build both kinds of services today. So we're going to start off. I've checked out I've cloned the repos for the front end, and we're just going to run Copilot init. Copilot init is the very first command that you'll want to run the first time you ever do anything with Copilot in your first repo. If you run it with dash dash help, you'll see that there's, lots of flags that you can pass. You can pass it an app name, a Docker file name, and so on. But what I love about Copilot is if you don't pass it any of that, it'll ask you. And so it's really, really simple just to get up and running. Would you like to use one of your existing applications? No, I'm going to build a whole new application, which again, application is those collection of services. I'm going to name it ECS Workshop. And then which workload type best represents your architecture. So for this service, this is my front end service. So I know that's going to be a load balanced web service. And then what would I like to name my load balanced web service? I'm going to name it ECS Demo Front End. Where do I find the Docker file that I want to build and deploy? And it did a search through my code. Remember when I said Copilot lives with your code? Well, there's a good reason for that. It can introspect your code and figure some things out for you. And so it discovered, hey, there's a Docker file, but there's also a dockerfile.cdk. Which one do you want to use here? So I'm just going to use the plain Docker file. And then it's going to go ahead. Now, let's look at the message real quick. It says, okay, great. We'll set up a load balanced web service named ECS Demo Frontend in application ECS Workshop, listening on port 3000. That's another example of how living with the code, it figured out the port number. It never asked me. Now, if it couldn't figure it out, it would have asked me. But because it was looking at the code, it was able to just discover, hey, this is port 3000. So I already know that. I'm just going to go ahead and run with it. Now, remember that diagram that we looked at? It's going off now, and it's building all of that environment, all of that infrastructure, and it's going to then bring it all up, and we're going to launch our container into it. So would you like to deploy a test environment? That test environment is the testing stage, perhaps, in my pipeline. So I'm going to go ahead and bring that up. And this part is going to take a while. This is going to take about 10 minutes or so. So while that's happening, we're going to let this run and we're going to come back to it. I want to come over here and let's just take a look at some more Copilot options. If we just look at Copilot dash dash help, you'll see that there are different commands and they're all broken into different categories. So we did Copilot init, which is in the getting started category, and that's great because we're getting started. There's also Copilot docs, and you run that. It would normally, if you were not in Cloud9, if you were in your own terminal, it would open up your browser to the documentation. I think that's kind of handy. Then we have develop, release, add-ons, and then some settings. So for develop, we have commands that you might run for your application. Then we have commands for environments, commands for services, jobs, and tasks. So if we explore that a little bit, Copilot app, you can see that for a given app, we can run Copilot app init, which will create a new application for us. And again, application is a combination or collection of services. Copilot app ls will just show us the applications that are in my accounts. And it's talking about my AWS account. So Copilot app ls, we see that there's the one that I'm bringing up now, ECS Workshop. There's one that I have called Watches, and then there's one called Workshop Demo. So these are running somewhere in my account. Could be a different region or whatever, but all in this account, and Copilot can help me manage everything. Of course, if you want more details, you can show any of these, and if you want to delete all the resources for a given application, you can delete. You can do app delete. Let's go back and let's look at. We'll check on, by the way, we'll check on our progress here, and you can see that we are creating the infrastructure for ECS Workshop, the test environment, and it's showing it. I love this display, by the way. It's blown up a little bit here, and the carriage returns are kind of hampering our visibility. But in a normal terminal, normally sized, you would see this formatted really nicely with the counters telling you how many seconds it's been since we've started this particular step. So it's giving you an idea of the progress. Now, of course, let's think through what has to happen. We're building the infrastructure right now, or Copilot is. What'll have to happen after we get the infrastructure is we're then going to have to build our application using Docker build, and then tag it, and then push it into a container registry, in our case, ECR. Then we're going to have to build, if you don't know this, by the way, it's okay because you don't have to think about it if you use Copilot. But we would then have to build, okay, here's our Docker build happening. We would have to build the task definition after that, and then the service definition, and then deploy our service out to ECS. And so Copilot is going to take care of all of these steps in succession without us having to worry about them or really even know about them. So you may not know exactly the best way to do a Docker build. Copilot will take care of that for you. And your tagging strategy, you may not realize that it's really nice to tag your Docker images according to your Git hash. So Copilot will take care of that for you. It builds the ECR repository, and then it sets the permissions accordingly so that we can pull images out of there. So we moved on now to, we have our infrastructure built. So now we're moving on to building and deploying the service. So we've built the container. It's now in our registry. And after that, we're going to be building and deploying the service. And even that has steps that you may not normally think of. You may not realize that there's an IAM role that needs to go with a service. And this allows your service to have certain permissions to be able to reach other AWS services and be able to talk to them if necessary. So it's good to have that in place so that you can grant access to a database if that's necessary, or an S3 bucket if you're going to be able to be storing objects and that sort of thing. Everything will need a security group. So we'll go ahead and build that, and then grant port 3000 traffic through that. So you get the idea. Copilot's taking care of all of those tiny little details that are necessary along the way. And here's our application load balancer right in the middle. That's now being brought up and provisioned, and it'll eventually be connected to our running service. So this is, again, it's going to take a few more minutes. So we're going to go back. We'll keep exploring. Let's explore the service. I think this is probably where we'll operate the most in Copilot. So let's look at what we can do here. Copilot service. And again, you can see the verbs here: init, ls, package, deploy, delete, show, status logs, exec. Exec is pretty exciting. I hope to show you that by the end of the demo. But you can guess service init, just like app init. Service init will create a new service inside an application. LS will list them. Package is interesting because I pointed out that Copilot takes care of the infrastructure as code for you. Package is a way for you to see what is it building? What does that end up looking like? So for our service here, our front end, if we do package, we get just a bunch of CloudFormation. And this is all YAML format. Let's just do a line count real quick. That's 519 lines of YAML that I didn't have to write. So I don't have to be an expert at all of these parameters where we reference other values and cross-linking, stack name variables and all that stuff. I don't have to be good at that. And I don't have to format all of this appropriately and all that stuff. Copilot just takes care of that for me. But if I ever become an expert or want to become an expert and I want to dive in deep and understand exactly what it's doing, then I can definitely explore this. I can either save it to a file or type it to less, and I can look at it right here on my screen and see everything that it's doing. So Copilot's not doing anything that's unnatural. It's definitely following the best practices of AWS, and it's doing things in an AWS native way so that if you ever need to walk away from it, you still can. You don't have to completely live with Copilot forever and ever, although you probably will want to. If you ever want to walk away, all that it's doing is it's building CloudFormation for you. And so you can take this CloudFormation yourself and you can save it to your own set of files, and then you can start to manage it by hand from here. And you can take care of it going forward and stop using Copilot if you ever have a reason to do that. Okay, let's check on our progress. Looks like we are, oh, this is fun. So we see that our service is going out. We have a desired count of 3. We have 3 that are pending, none that are running so far. So I love that I get to see the progress here, right here on my command line. If I'm the developer, I know exactly what's happening and where we are. And oh, look, 2 are now running and 1 is pending. And then once we get to the point where all 3 are running, We'll also have to wait for them to go healthy, and then we'll have to wait for the load balancer to have them registered. So it's not, now they're all running, but it's not done. It's almost done. We're probably another minute away from this being done. So while we wait, let's go back and let's look at service again. And let's just do status. So you can see that sort of like our output in the other tab, you can see that I'm running image digest. All three are the same image hash. This is also the Docker tag. They're all in a running state. They were started, 45-ish seconds ago, and there are no alarms right now. Okay, so our deploy is now complete. Everything is done and completed, finished, and you see that we deployed ECS demo front end, and you can access it and it gives us the URL for the load balancer. So I'm going to go ahead and click open, and you see that, oh, look, we have traffic. So we're running our front end in two availability zones. And this is what Copilot built for us. It wants things to be resilient and highly available. So it built a VPC with two availability zones so that we can run our application in both of them. And that way, if there's ever a problem in one of the availability zone, we'll still be up and running in the other. And this is just the kind of intelligence that Copilot comes with. It knows to do that automatically, and it's not something that I had to think to do on my own. So that's our front end. Now, I mentioned that there's also a backend API. So I have that checked out also, ECS demo Node.js. And we're going to add this into the application. So if we look at Copilot, let's figure out how to do it. We're going to do Copilot. In fact, I should actually just follow the workshop instructions. And let's go to the Node.js backend API. And you see it wants us to run Copilot init. Now, when we do that, it's going to notice, or it's going to ask us, what workload best represents your architecture, just like it did before. This time, before we picked load balanced web service, this time we're going to pick backend service because we don't need a load balancer. So this is just going to be a container or set of containers that will run in our same VPC on our same cluster, but they won't need a load balancer to be able to access. And what's the name of the backend service? ECS demo Node.js. Actually, when you name a service, I like to name it according to its Git name. So that often will be the directory that it's checked out into. That way things stay consistent. And if you ever have to troubleshoot something at 3 a.m., you'll be able to know, okay, well, this service that's in an alarm state and having problems is this container and this set of code. All of it matches the same name, and that way I'll know where to look for troubleshooting purposes. So I don't have to build the VPC, the cluster, all of that infrastructure again. We're going to use the same set of infrastructure, and then we're going to just deploy this application into that same set of infrastructure. So we're skipping past that first build out, and we're going to just immediately launch into building the container. And then see, here we go, building the Docker container. And then we're going to go into the deploy phase and be able to deploy this out onto that cluster. So this will still take a few minutes, less time than before, but still a few minutes. So here we are with kind of the same view as earlier, where we're building service discovery, the IAM role again. You'll notice we're not building a load balancer, no mention of that this time around. And CloudWatch log group to ship logs into, IAM role, and so on. So we're going to let this run, and let's go and keep exploring the Copilot CLI. So what did I do before? Status? Let's do show. And notice I didn't tell it an app name, but now we have, or a service name, but now we have two to choose from. So it's asking me, well, which one do you want to know about? Do you want me to show you front end or Node.js? And so if I do show for front end, I get lots of really interesting details here. And these are details that I might be able to find in various places in the console, but Copilot brings it all into one location for me and shows me all this stuff together. So you can see that I have this service deployed into a test environment. Here's the URL if I want to be able to reach out to that test environment and see it running. There's a service discovery namespace built, ECS demo frontend dot ECS workshop dot local is the service discovery name for this service. And then some variables, environment variables that are inside this container. So as my application is running, it has these environment variables set, and I might find these useful for finding more information about how the front end connects to another service, for example. So eventually, we're going to want the front end to connect to the Node.js backend API. How does it find it? Well, we're using service discovery, and there's already in the front end environment the location of the Node.js backend API. It'll be found at nodejs.ecsworkshop.local port 3000. So we'll be able to locate, or the front end will be able to locate the backend API and send traffic to it as soon as it's up and running and healthy. So we see that, oh, look, we just flipped over in time and ECS demo Node.js is up and running, and its service discovery endpoint is, just like I said, ECS demo Node.js.ecsworkshop.local port 3000. So that means the front end should be able to reach it. And sure enough, as we look at our front end now, you see that I have my three, looks like if we watch here closely, you'll see three different IP addresses rotating through, running in two availability zones, reaching the backend API, where there appears to only be one of them running in one availability zone. And let's just confirm that. Let's do Copilot service, and we'll do status for Node.js. And you see, sure enough, active one running task. Well, what if I want this to be resilient also? Obviously, I don't want any single points of failure. So how do I scale this up? I did this ahead of time for the front end, but I didn't do it for the Node.js app. So let's do this now. In my code, remember when I said Copilot lives in the code? So this is my code for the Node.js application. And inside of this, there's a directory called Copilot. And inside of Copilot, there's ECS demo Node.js, the name of my service. And inside of that, there's a manifest file. So this is the manifest file for ECS demo Node.js. And this gets automatically created when you Copilot init. So if it doesn't exist already, Copilot will build it for you, create it for you, but then it fills in some of the values, some of the defaults. Well, one of those is how many should there be? And if you're in a dev environment, or maybe even in test mode, you don't need a bunch, right? But if you're wanting this to be production quality, you want there to be no single points of failure. So instead of one, maybe I want there to be two. I'm going to go ahead and change that and save. And I'll close this. Now let's commit that change. Um, Git commit. And we'll just say that we're updating. And then we will service. And this time we're going to, I'll show you, we're going to deploy. We're going to deploy a service to an environment. So we're building our container. That part's done. We've pushed it to ECR. That part's done. And now we are proposing the infrastructure changes for the stack. So we're going to deploy our new container. And we're not only going to deploy the new container, but we're also going to deploy 2 copies of it. And the default is for those 2 copies to go into 2 different availability zones. So the end result should be, you see that the active one right now is 4, number 4, and we're proposing to roll to number 5. And you see that the old desired count was 1, but the new desired count is 2. We already have 2 that are pending. Those will end up going into a running state. Then, once they're marked healthy, this will drop from 1 running to 0 running, and will eventually drop 4 completely off the picture. So maybe take note also, the one that we'll be replacing is 1.148, and we should end up with 2 new containers, none of which will have this IP address, and both of which will be running in AZA or AZB. Also, this hash is going to change from C61D. So 1.148 and C61D, both of those things should end up changing. All right, so how are we doing? We have 1 running, 1 failed, probably failed its health check. But when it fails, it's going to attempt to bring another one up to replace it. Yep, failed container health check. I think I probably have the health check a little bit too sensitive. Need to dial that back a little bit. And since we're here and talking about container health checks, if we look at the Docker file, the health check, this is the health check that it's complaining about. So it probably just is a little bit too aggressive when it comes up, and it failed, the first time or something like that. So we have 1 running. We'll let that keep working. The last thing that I want to show you while that's up and running is one of the very newest features for Copilot is to add in exec functionality. So prior to Copilot having exec functionality, there wasn't really a good way for you to troubleshoot a running container. Our containers through Copilot are running in Fargate, so that you don't have access to be able to SSH to the EC2 instance, Docker exec into the container, and all that stuff. Because there is no EC2 instance, so there's nothing for you to SSH into. But what we did is we built in the ability for you to, in a secure way, exec from your terminal directly into the container. So if I copilot service exec, it's like usual, it wants to make sure, okay, which are you talking about, front end? And since I didn't specify a given task, it'll just pick one for me at random, and look, it dropped me into it. So I can see this is my running application. I can see the processes that are running here. And if I want a slightly better shell, I can type bash, and now I'm using the bash shell instead of the Bourne shell. And I can cat, startup .cdk.sh, and I can see this is the startup script for running this application. And I could troubleshoot from here. I could curl things, or I could look to see, what's happening in my container. So Copilot Service Exec. This is super handy, also super new, and I want to make sure that you're aware of it. If we run it through help, you can see that you can specify the app name, or you can specify the container string if you want to get into a specific container, or task ID if you want to get into a specific task. Usually, I don't have to, if I'm going to troubleshoot something, any of the running tasks are fine for getting into, so I don't have to really focus on that. So all I end up typing is Copilot Service Exec, and then I'll pick whichever I want to get into, and get a shell session directly in there. So that's it. Let's check our deployment. Looks like we have our 2 running tasks now. So we're just waiting on, I think, the old one to go away. There it is, it's done. And now we'll go back, and sure enough, we see at least one of them is healthy, but the IP address has changed, 10.0.0.8, and now you see we're sending traffic to 10.0.1.7 as well. We're in 2 availability zones now, and our get hash definitely is different than it was before. So this is Copilot. We were able to get up and running. We brought up a front-end microservice, a back-end microservice. We have service discovery set up. We have troubleshooting using Copilot Exec. We have log aggregation. We have metrics. We have health checks. Everything working as expected. All right. Thank you very much. And if you want to follow even more about Copilot and learn more about running microservices on ECS, definitely check out ecsworkshop.com, and you'll see all of this and more here on ecsworkshop.com. All right, so now that we've seen the demo of Copilot, let's just take a quick review. What have we seen? So we learned that ECS is a managed container orchestrator, so it's not something that you have to figure out and become an expert in. AWS and Amazon ECS provide tools that are tailored to your needs, so you can choose your own path, whether it's running through the console, or whether it's building using infrastructure as code, perhaps using the CDK, or Copilot, which gives you kind of a combination best of both worlds experience. Copilot's focused on getting you up and running on ECS in minutes. It's the easiest on-ramp for getting your container running in the cloud. And then it provides observability out of the box. So it doesn't stop at just deploying your container. It is something that will carry you through all the way through all of your operational responsibilities. If you want to learn more about ECS, check out the ECS landing page. Or if you want to learn about Copilot, we have the open source project, github.com, AWS Copilot CLI. We're also using Copilot in ecsworkshop.com, so check that out. And then we've talked a lot about Copilot on Containers from the Couch. And if you haven't seen that show, definitely check that out as well. Thank you. Again, my name is Brent Langston. You can reach me on Twitter at BrentContained. And if you want to reach out by email, I'm blangs@amazon.com.